Hello folks, today I want to talk to you about one of these. Now this is a microphone, and it's a type of microphone that a band would use to sing out with a band, and it's called a dynamic microphone. Now a dynamic microphone, that works more or less in the reverse of a speaker. So in a speaker we had the diaphragm which pushed a coil through a magnet. What this is going to do, the speaker is pushed by a coil through a magnet. What we've got here is something called a diaphragm. So if I just draw you a quick picture, the microphone has a diaphragm. Funny spelling word. And just here is attached a magnet. And that magnet passes through a coil. Now, if you look closely inside of here, what you will see is the coil just there. You should be able to see the coil there. And that's the thing that the magnet's passing through. And looking through at the end there, you can probably even see the magnet and the diaphragm. So that's the main thing what I wanted to talk to you about. Now what happens is, as sound comes into here, and we know that it travels in these waves, so that it comes in pulses, it pushes the diaphragm backwards and forwards. And what that does is it induces current in the coil. So as the magnet, which is what this is, as that passes through the coil, it induces a current. And as it goes that way, it gives a current going in one direction. And as it goes that way, it gives a current going in an opposite direction. So as that's moving backwards and forwards, it encourages a current, a positive, negative current. And you start to see that appear into sort of a wave pattern. Maybe with a central bit just there. And I'm going to show you something in a little while which will show how that happens in an electrical point of view as well. Now that's one type of microphone, the vocal microphone, which we know as a dynamic. Now another type of microphone that we have is called a piezo microphone, and you would get one of those on one of these. So guitars and violins all work the same sort of way. When you pluck a string, that causes this piece of wood here to vibrate, and then this piece of wood here, it is really thin and it starts to vibrate as well. And it causes this big movement of air within this big box, and that is focused and comes out through the sound hole. So one of the key things about a guitar is that it's all about this movement of air up and down that is allowed out here. Now how can we then amplify that? How can we microphone that? Now it'd be quite awkward to stick a microphone in front of here, but some people do that. But it would be much better if we could connect it up to the electricity. And the thing that does that is something called a piezo pickup. And that's something a little bit different still. And it's based on a particular type of crystal. So a piezo crystal. Right, and a piezo crystal is a crystal, as it says, and it's connected up to the electricity, so there is a charge coming through it all of the time. So one of the features of my guitar there with the piezo pickup is that it's got a battery. So there's always a current going through. But a piezo crystal is really sensitive to pressure. So as soon as any pressure comes on or off, it alters the resistance of that crystal. So basically what that means, that crystal lets more current through if there's pressure on it and less current through if there's less pressure on it. So basically, as our pressure wave is coming on and off and on and off, remember we said about sound coming to the object and away from the object and to the object and away from the object, then it creates a change in the current. So this is the normal current, and when we put some pressure on it, it changes the current like that, makes it go higher, and when that comes down, makes it go lower again. So when it's below the normal pressure and when it's above the normal pressure, so you end up getting a current that's above the normal, below the normal, and of course it doesn't go smoothly between those two things. So it'll come like that down to below the normal and back up in this wave pattern that we call a sine wave. And when you get into year 11 in your maths lessons, you will see what a sine wave is all about. And you can see in here, we've got a similar sort of shape here and here. And that shows the current coming up and down and up and down as this magnet here is coming backwards and forwards, and in here as the pressure is coming higher and lower, higher and lower. And that's basically, that then creates an image. That we can pick up on something called an oscilloscope. Now an oscilloscope works with the microphone in your device, and it shows the current going up above the normal, behind the lower level, and above and below. So you can see that quite nicely being altered by my voice as I'm speaking. Now I can create some sounds for you to see. This particular thing's got a piezo pickup. One of the big things about a piezo pickup is it's really small. So using a piezo is what's in your mobile phone, of course. So I might want to give you some sort of, sorry, I'm on the wrong thing. So I'm going to play some sounds on my frequency generator here, which you can't hear that well. Generally our hearing picks up about 22 Hertz. You can see that wave getting faster and faster. I can start to hear that here, but you probably can't just yet. Let's progress it up a bit quicker. You can see a slight alteration in the wave there now. And there you can see a nice even pitch at 618 Hertz. The key thing you should notice here is that in comparison with the previous, the waves they get closer together as the higher pitch you get. And that's really quite annoying. So what that will do is show you how a different pitch alters it. So on the oscilloscope, that shows the change in current. For a dynamic microphone, your centre point might be 0, but for piezo there will be some given central point, and it shows some positive and some negative, as those pressure waves do one of two things: alter the resistance of the piezo crystal, or move that diaphragm backwards and forwards. They're giving it pressure and letting it relax back, and they go either side of a different point. Now, I'd like you to remember I called this a sine wave. And in our next lesson, we will have a look at how these sine waves differ according to different sounds. I gave you a little bit of an example there on my oscilloscope, but hopefully for now you can see that the piezo pickup in there is causing the graph to go above and below the central point, which is what I wanted you to see.